Hello and welcome to my next tutorial on vector geometry. So in this tutorial we'll be looking at a formula called section formula in vector, and we're going to prove that we're going to derive the formula for internal division. At first what I'm going to do is I'm going to take point AB on our plane, and here I'll suppose that point M, it divides the line segment AB internally because this point M lies in between the line segment AB. So this point M, which is inside line segment AB, divides the line segment AB in the ratio M is to N. And I'm going to take a point O, which is origin, and if I try to join point O to A and point O to B, similarly point O to M, we have here a nice little triangle. Here what I'm going to do is I'm going to I have drawn a position vector for point A, point B, as well as for point M. So position vector is a vector that is drawn from point O or origin to that point, so it represents the position vector of that point. Here I'll suppose OA as vector A, OB as vector B, and OM as vector M. So this is what I've supposed. Now I'll apply some rules like triangle law of vector addition and try to prove the formula for internal division. So here at first I'm going to take vector OM. So according to triangle law of vector addition, vector OM we can write as vector OA plus vector AM. So OA plus vector AM, that means moving from point O to M is same as moving from point O to A and then from A to M. So finally we have reached point O from point M. So although the path is different, the destination and the source or the point of origin is the same. So according to triangle law of vector addition, we can write OM is equal to OA plus AM. So if we just cancel these two, we can see here OM on the right hand side, and on left hand side as well we can see vector OM. Now if we talk about this vector AM, we can see that vector AM means moving from point A to point M, and it has the length M. But if we talk about this whole line segment AB, we can say that AM is something ratio of AB. So we have to find what this really means. Here, since we have since point AM has length M out of the total length M plus N, so we can say that point AM, it occupies M by total, which is M plus N part of this whole line segment AB. I hope it is clear to you up to this point. So we can simply add a vector sign here. So AM is equal to M by M plus N times vector AB. So it means vector AM, it occupies M by total part of this whole vector AB. This is the concept of fraction which I've applied here. I hope it is clear to you. Now point OM is equal to, I've supposed vector OA as vector small a, and here for AM I'm going to write the same formula here, M by M plus N times vector AB. Now what I can write for vector AB is that if I take a line segment AB and I have a position vector for A and B, which is OA and OB, so here moving from A to B means vector AB. So moving from A to B is same as moving from A to O, and then from O to B. So here I can write vector AB is equal to vector AO plus vector OB. Again, what I can do is for vector AO, I can write minus of vector OA since it has same direction, but the AO and OA, they have same magnitude but their direction is different, so I've written a negative sign here after changing vector AO to OA, and then I can write OB as it is. So if I bring OB here and then take OA back, so I have vector AB is equal to vector OB minus vector OA. This is what I'm going to replace for this vector AB as vector OB minus vector OA. So here vector OM is equal to A plus M by M plus N times for AB I can write OB minus OA. Now I'm going to write it over here. Vector OM is equal to, for vector A I'm going to write it as it is, and here I have M by M plus N. For OB I can write vector B, and for OA I can write vector A. So here B minus A. Now I'm going to simplify. Here I have M plus N as LCM, and I will have M plus N times vector A plus here I have M, which is the magnitude or the ratio, and here I have vector B minus vector A. Once again I can write OM. Now if I try to distribute this vector A, I have M vector A plus N vector A plus, now if I distribute M, I have M vector B minus M vector A divided by M plus N. Now I can simply cancel MA and minus MA since these two vector has opposite sign, and here I have OM is equal to NA plus MB divided by M plus N, and here we have our section formula for internal division. I hope it is clear to you, and thanks for watching.